Hello students, welcome to this lecture on chemical bonding and molecular structure. We know Lewis concept is very much helpful in writing the structure of the molecules. But when we are talking about the shape of the molecule, we cannot able to predict from the Lewis concept. To remove these drawbacks of this Lewis concept, in 1940, two scientists, Sedgwick and Pearl, has put forward one very important theory, that is the valence shell electron pair repulsive theory. And from this theory we can able to understand, able to predict the shape of the covalent molecule, and this theory has further been modified by two scientists in the year 1957 by Gillespie and Nalham. And this theory is basically based on the repulsive interaction of the electrons pair in the valence shell. So today's lecture is the valence shell electron pair repulsive theory. So today we are going to discuss this very important theory. This helps us to predict the shape of the molecule. This is the valence shell electron pair repulsive theory, and in short form it is called VSEPR. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Now let us understand what is the basic concept, basic theory behind this concept, that is the valence shell electron pair repulsive theory. That you can understand from the very heading of this theory, that is the valence shell electron pair repulsive theory. And it is based on the repulsive interaction of the valence shell electron pairs. As the electrons are negatively charged, they are going to repel itself with each other, and that is the main thing in the molecule. Suppose we are talking about we want to predict the shape of H2. What will be the shape of the H2? We have to predict. For that, this theory says the shape of the H2 molecule depends on the valence shell, number of valence shell electron pairs of the oxygen molecule. Oxygen molecule in this molecule is the central molecule. So when we are talking about the shapes of the molecule, as per this theory, it is the central atom which is going to impact on the shape, or you can say geometry of the molecules. As the electron is negatively charged, it will repel with each other. And due to this repulsive interaction between these electron pairs, what is going to happen? They will align themselves in such a manner so that there will be the repulsive interaction between them will be minimum, or we can say there is no repulsive interaction. And in this process, what is going to happen? The energy of the molecule become at a minimum level, and the molecule will achieve the stability. And that is the very basic thing for chemical bonding that we can understand. That is, the molecule will achieve a state which is having a minimum amount of energy. Okay, so this alignment of these electron pairs will give a geometry to the molecules, and that is the basic theory behind this theory of the valence shell electron pair repulsive theory. Okay, so valence shell will repel with each other and it will align itself, and with this alignment they will achieve a definite geometry among the bonds, and the bond angle will be accordingly the to minimize the repulsive force between them. There are basically two types of geometry in this lecture we will understand. One is regular geometry and other is your irregular geometry. Regular geometry means regular geometry. Regular geometry means when the central atom. Regular geometry means central atom, we can write central atom is surrounded by similar type of atom. Similar type of atoms and bond pairs. This is called regular geometry. And irregular geometry of the molecule is when central atom is surrounded. Central atom is surrounded by different atom or electron pair and bond pair, lone pair and bond pair, lone pair and bond pair. Geometry, we will see that one is regular geometry, another is irregular geometry. Irregular geometry is occurred, irregular geometry will observe in the molecules when there is accompanied, when there is surrounded by that different types of atoms, or it is surrounded by lone pair and bond pairs of electron. Because it has been observed, it has been explained by two scientists, Gillespie and Nalham, in the year 1957. What they say that there is, you can understand the different types of valence electron has been divided into two parts. One is the lone pair electron, other is the bond pair electrons. The electron has been utilized as lone pair and bond pair, and it has been observed bond pair lone pair repulsive interaction. Why it is so? Because the lone pair reside in the central atom and it has taken a lot of space as compared to the bond pair in between the atoms. So we can write this very important thing that you need to understand, that this is a very important thing that you need to understand when we are going to explain the shape of the molecules as per the valence shell electron pair repulsive theory. That is, lone pair repulsive interaction is the maximum, followed by the lone pair bond pair repulsive interaction, and bond pair repulsive interaction is very minimum as compared to the other two things. Okay, and this you have to understand very well, so that you can able to understand the geometry of the molecules very well. Now we are going to understand the geometry of the molecules, how we can able to predict from the lone pair and the bond pair present in the central atom. The shape of the molecule is depend on the shape of number of valence shell, number of valence electron present in the central atom. That is the basic theory behind this VSEPR theory. Okay, going to understand how from the one pair, this is one pair, BP means one pair, and this is lone pair. Arrangement of the electron pairs, geometry of the molecules, mole monomolecules, shape, total number of electron pair, and the molecule type. Suppose we have taken first the molecule type is AB2. And that things the number of electron pair suppose 2, and this electron pair is utilized in the bond pair. Bond pair is 2, there is 0 lone pair, and the arrangement of the electron pair will be, if it is a central atom A, then the electron pair will be arranged at the linearly. That is the arrangement of electron pair, we can say it is linear, because in this position there will be the least repulsive interaction between the electron pairs. That here it is a bond pair. Now what will be geometry? Geometry will be the linear also. So when there is a two electron pairs and which is utilized as a bond pair, this geometry will be linear, and arrangement of electron pair will be linear, and geometry will be linear. That is a regular geometry, and its safe molecular geometry. And the example of this, suppose BCl2 HgCl2. For this molecule we can observe its geometry, shape of the molecule is linear. Now molecule type we are taking AB3. Here the number of electron pairs is 3. Bond pair suppose it is 3 and lone pair is 0. At that time what will be the arrangement of the electron pair? Electron pair will be arranged in a trigonal planar structures. This arrangement of the electron trigonal planar structures, and there will be the 120 angles between this bond, and we can write this is trigonal planar structure. That is the arrangement of the electron pair. And what will be the geometry of the molecule? It will be same, that is trigonal planar. It will be same trigonal planar. Example of this you can see BF3 or LCl3. Okay. Now we are going to the another type. Suppose this molecule type AB2L. L means in this molecule there is a lone pair. Apart from the bond pair there is a lone pair, but total electron pairs is 3 and the bond pair is 2 and lone pair is 1. So what will be the arrangement of the electron pair first? Let us see. Electron pairs arrangement will be same trigonal planar. We can write this, it is same trigonal planar. Trigonal planar. But due to the presence of the lone pair of electrons, its geometry will be V shape, bend shape. Its geometry will be bend shape, and his example is, you can see O3 SO2. So you can understand this is now a irregular geometry. That electron pair arrangement and actual geometry of the molecule has been changes. You can see it is the trigonal planar arrangement. The electron pair has been arranged trigonal planar way. But here the molecular geometry you can see it is a bend shape. The example is O3 and SO2. See how electron pair is going to influence the lone pair electron, going to influence this structure, molecular shape of how it is in shape, that is a trigonal planar, now it is a beam shape. Now we are taking another example, AB4 type of molecule. Here the electron pair is 4. Suppose all this electron pair has been utilized as one pair 4 and it is lone pair is 0, and at that time what will be arrangement of the electron pair? Electron pair will be arranged in a tetrahedral structure. Electron pair will be arranged in a tetrahedral structure, and here the bond angle will be 190 degree 5 minutes. Now what is the geometry of the molecule? Because here is no lone pair, so its geometry will be same, that is tetrahedral. And its example is CH4, NH4 plus. Okay, so we understand this is the arrangement when there is a 4 electron pairs in the central atom. At that time the arrangement of this electron pair will be tetrahedral, and as because there is no lone pair, it will going to we have the same, the molecular geometry, shape of the molecule will be same as the arrangement of the electron pair, but it differs when there is a presence of the lone pair. I can see both the instances. Now suppose in this molecule AB3L, where you can see one lone pair is there, 3 lone pair is there, the total electron pair is 4, bond pair is here 3 and lone pair is 1. At that time the arrangement will be tetrahedral. Arrangement of the electron pair will be tetrahedral, but the shape of the molecule will be different. Shape of the molecule will be trigonal pyramidal. Shape of the molecule will be trigonal pyramidal. Due to the presence of the lone pair electron, one lone pair electron, its regular geometry has been changed. Regular geometry will be tetrahedral, but when the presence of one lone pair, it will become the trigonal planar. Now the example of this is ammonia, or you can say pH3. All these will have this type of shape. So we can understand how the shape is being regulated, controlled by the electron pairs and the bond pairs. Okay, now we are going to discuss another type of the molecules. You have to understand the type of the molecules, because in the exam you have been given, suppose tell the shape of this H3O plus, then how do you able to understand? First you understand this, then we can go for how we can easily solve it easily. We are going to discuss the AB, we have discussed the AB3L, then we are going to discuss AB2L2. AB2L2, the total number of electron pair will be 4, same. Here bond pair is 2, lone pair is 2. At that time arrangement of the electron pair will be tetrahedral. Arrangement of the electron pair will be the tetrahedral. But here there is a 2 lone pairs of electrons, you can see. 2 lone pairs of electrons. So the geometry of the molecule will be V shape, but you can say bend shape, due to the presence of the 2 electron pair. This type of molecule is H2O. H2O will have this bend shape. In spite of this fact, their electrons are arranged tetrahedrally, but due to the presence of the lone pair electron, 2 lone pair electrons, its angle is different. Its angle changes from tetrahedrally, it will be 109 degree, but it will have the 104 degree due to the repulsive interaction of the lone pairs of electrons. So now we are going to discuss another molecule type, that is AB5, where the bond pair electron is 5, total electron pair is 5, and here also the bond pair electron is 5 and lone pair is 0. At that time, what is going to happen? The arrangement of the electron pair will be trigonal bipyramidal. Trigonal bipyramidal. Pyramidal. So in this type, as there is no lone pair is 0 and geometry of the molecule will be same, trigonal bipyramidal. Gonal bipyramidal. Bipyramidal. And its example is PCl5. So, arrangement of the electron pair and the geometry of the molecule same. Now, we have another shape molecule type AB4L. Here, one lone pair is there. Electron pair is 4. Electron pair is 5 here. But it is will be distributed into the bond pair is 4 and lone pair is 1. At that time, the electron will be arranged, electron pair will arrange in this fashion, trigonal bipyramidal. But its geometry will change. Its geometry will be seesaw. The example is SF4. So its arrangement of the electron is this, trigonal bipyramidal, but it will have the seesaw structure because of the presence of the lone pair. Another type, that is AB3L2. Here, total number of electron pairs will be 5 and the bond pairs of electron will be 3 and lone pair is 2. So, in this type, the electron will be arranged, electron pair will be arranged in the same fashion, that is trigonal bipyramidal arrangement, but its shape of the molecule will be different. How it is different? At that time, you can see its shape will be T shape. And example of this, ClF3. Okay, now we are going to discuss another molecule type, that is AB6. Here the electron pair is 6, bond pair is 6, lone pair is 0, and arrangement of this electron pair is the octahedral arrangement pair. Arrangement of the electron pair, octahedral structure. And its geometry of the molecule also be octahedral. An example is SF6. Another type, that is AB5L. L means lone pair. Here also electron pair is 6, bond pair will be 5 and lone pair is 1. Here also arrangement of this electron pair will be octahedral, but its geometry will be square pyramidal. Its geometry will be square pyramidal. Example is, you can say this is BRA5. Another example of this variety is AB4L2. 4L2. Here you can see electron pair is 6. Total electron pair is 6, but here the bond pair is 4, lone pair is 2. Here also arrangement of the electron pair is octahedral, but the shape is square planar. Shape is square planar. Example of this: so you can see there is a regular geometry when the central atom is surrounded by the bond pairs only, and when there is the presence of the bond pair and the lone pair at the same time, the geometry has been distorted to another shape. And now question arises, when in the exam it will come, at that time you cannot able to memorize all the molecules and all the molecule types, but you can have to make some points by way we can able to understand the first the molecule type, and from this we can able to say about predict about the shape of the molecules. That we will now understand. Suppose you have been given hydronium ion, tell the shape of this molecule. At that time what we will do? So you can understand, you need to have the information of which types of molecule it is. If it is a AB2, then it will be linear. If it is AB3, then it is a trigonal planar. If it is AB2L, it will be the V shape. This you have to first identify which type of molecule it is. For that, you have to know the total electrons. T is the total electrons, and that we can able to calculate from this formula. Half into this is the formula to find out the total electrons. T is basically the total electrons. Total electron. Okay. Now we have to know the bond pair electrons. For this, another term, bond, B. B is the number of atoms bonded by single bond, or we can write this number of atom linked by single bond. So from this we can understand A lone pair is equal to T minus B. This is the formula, and here you can apply this formula. You can first you have to apply T. You have to know the T. Half into central atom, the valence electron central atom is 6, plus number of atom joined with a single bond with the central atom, it is 3, and it is a plus, so there will be minus 1. So you can understand it will have a total 4. So lone pair L is equal to will be T minus B. T is given here 4 and B is 3, means it will have the one pair of lone pair electrons. One lone pair of electrons mean this molecule type will be, we can say, AB3L. So when if it is AB3L, means total number of electrons was how much? It is 4. If it is 4, the arrangement of electron pair is tetrahedral, but due to the presence of the lone pair, its actual shape will be changed. Shape will be trigonal shape will be trigonal pyramidal. Trigonal pyramidal shape of this species. So in this way, we can able to say the shape of any type of molecule. You have to convert it first to which type of molecule it is by this formula, by knowing this lone pair of electrons and one pair of electrons. Then we can able to calculate this. It is very easy. That is all for today's lecture. Hope you understand all the points that I am clarified, because this is a very important chapter, important topic in this chapter, because 1 or 2 questions must going to come in your exam, both IIT, JEE or in your board exam. If you have any doubts, you can comment in the section box. If you like this video, we can share it to your friends. Thank you very much for watching.